The following is brought to you by Total Seal Piston Rings, the leader in ring seal technology. TotalSeal.com. Hello and welcome to another edition of Hidden Horsepower, presented by Total Seal. My name is Joe Castello. You can find me on Twitter and Instagram at WFOJoe, and I am super excited to be back. So many people reaching out and, saying they like the podcast, and I am definitely not the reason. I know that. I know who is the reason, and he joins me now, Mr. Keith Jones from Total Seal headquarters out there in Arizona. Keith, long time. How are you doing?
I'm doing great, Joe. I hope you're doing very well. It's been a little while. We got we're jumping back into this thing. We've gotten, we'll say, through a little break there, and we're here we are, going strong, having a great day. Looking out the window, it's a sunny day, about 80 degrees in Arizona. Hopefully, everybody listening is having a wonderful day as well.
Well, exactly. That's what it's all about. And we've had some amazing episodes to start the 21 season, and it's been great. But we're going to keep building upon it. Today, we're going to have Chuck Lynch, who is the Director of Technical Services at the AERA, which if you're an engine guy or machinist, if you are looking for the right way to do things, all the way back to the 1920s, like a part, a piece, an engine, a spec, they keep all of it. So I am super excited to hear the two of you guys go back and forth and dive into this. We're going to talk ring seal. We're going to talk valve seal. We're going to talk gasket seal. We're going to get into a lot of things that I know the Hidden Horsepower audience is stoked to find out about. I know you are too, Keith.
Absolutely.
Well, let's bring him on. Without further ado, from the AERA.org, he's the Director of Technical Services, Mr. Chuck Lynch, joining us on Hidden Horsepower. Chuck, welcome.
Thanks a lot, gentlemen. Appreciate the opportunity to be on the show.
Now, thrilled. And you're also a podcaster. Let's just throw that out right away. The podcast audience, it's exploding. People like to listen while they work. You are a podcaster. Do you recommend they listen while they work?
Absolutely. It's great for the commute, but the nice thing about the audio podcast is the fact that you can still be busy at your job. I usually have podcasts going all the time in between calls. You can quick and easy mute. You're learning while you're doing research. So if you're spinning wrenches, running machines, whatever the case may be, podcasts are great. I seldom ever listen to music or anything anymore. It's all
information.
An opportunity to gain some information.
That's
exactly.
It. Well, and years ago, Keith, we talk about this all the time. To seek out information was a challenge. You're in your town, your county, your city, wherever you happen to be, and you want information about insert subject here, right? Ring seal, engine building. How do you find it? There were maybe 2 or 3 guys that had the information, and how good and reliable was it? We are in a different world when it comes to finding out the best, most efficient way to handle a project.
Yeah, absolutely. I mean, we've got, not only the podcast information, when we can seek and find good, valid information on the internet. As you said, in the old days, you had to find that guy, and hopefully that guy was willing to take the time to take you under his wing, share what he's learned over all the years, what's been passed down to him. And as much of that as there still is out there, I don't think it's anywhere near as what it used to be. So we have to rely on other sources, schools, what we can find is stated, through the online sources and podcasts. This is a new wave, a new age. And we've got to get that information out there because this is, we don't want this to shrink. We want it to grow.
Now, this is a particularly busy time for you, Keith. Why don't you get us up to speed a little bit, and then we'll dive in with Chuck on some information. But you're hustling, right? We had to pry you away for this episode.
Yeah, you did. It's pretty insane out there. We'll just say I will apologize first and foremost to the industries that have been affected by the virus. There's a lot of people that are struggling. There's a lot of people that are out of work. The automotive and performance world, and you hate, I don't want to throw that fuel on the fire, but it's blossomed. People are, they're not going to the movies, they're not going on vacation, they're not going out to dinner. They're looking for hobbies, they're looking for things to do. So they've turned to, performance streetcars and restorations. I like to say it, planes, trains, and automobiles. We're doing rings for everything because everybody's kind of turned back, to the old days, and, they're working on their stuff. They're working on the projects that they've been going to work on for, 20, 30 years, whatever that is. They've got that old tractor in the back, that old CUDA that's sitting in the backyard. I'm finally getting around to it, and it's just exploded, this industry, and it really hasn't settled down. And now we've got, the racing industry looking at us, right down the road, not too far. The race season is going to start again, so those guys are on fire building. And so we'll just say it's a busy time right now. It's pretty crazy.
Chuck,
we embrace it and we welcome it.
Are you finding that to be true also, Chuck?
Very much the case. So in our tech group, we jokingly talk about this. It's like everyone decided to drag out every project they could possibly get their hands on. Hey, I'm going to restore Granddad's old tractor. It doesn't matter if it's a four-door sedan or whatever. If it has something, the legacy of the family or whatever, those projects are coming out. So that is definitely what we're seeing on the tech line.
Wow, tremendous. All right, before we get into some actual tech talk, which I'm excited to hear you guys go back and forth on a couple of different subjects, but let's talk a little bit about the AERA. And this is an organization that has been around for a long time, and it's kind of like, benchmark information. Why don't you explain to our listeners out there, many of whom want to build engines themselves, some of whom are just listening for entertainment?
So objectively, AERA come from the fact that stuff wears out, and we jokingly say that we were probably the original green movement because of the investment that you had in a vehicle. Investment in a vehicle now is great. It was really a big deal in 1922 when AERA came to be. So in an effort to keep the stuff reliable and on the road, a group of machinists of car dealers and so forth, they got together and said, hey, we need to be able to support this. So we're coming up on 100 years, and now our mission is engines. It's not so much the Automotive Engine Rebuilding Association, but it's the Engine Rebuilding Association. Probably 50% of the calls we take now are diesel. A huge percentage are industrial application. So what we do is compile data from all the engine manufacturers globally that we can get our hands on. And sometimes it's a challenge, but hey, we all like a good challenge, right? So we compile as much information as we can, and we have what we call our flagship program is Process, where we put all of the OE type specification stuff. We typically do stick with the OE specification. So if you're going to look for a cylinder bore, we wouldn't necessarily have 10, 20, 30, 40 over or whatever. We would have the base data, and then we know that it gets modified or manipulated from that point based on application. Performance World being a perfect example of most things get tailored to the application, but we have the base information for that 5.3 LS engine or the 5.7 LS or the old 350 Chevy or the Model A Ford engine, or if you're in the diesel performance world, we have the contacts to help you get to the right person if you do want to do the performance stuff. And we're friends with all the part suppliers, and they advertise in the Engine Professional magazine, which is another one of our outreach tools. And again, it's about networking and sharing information and helping our industry grow and thrive and continue forward.
I love what you're doing. I love that it's a resource, and in many ways you guys are like the protectors of the scrolls of engines going all the way back to the very beginning, and if someone wants that information, they can find it. You referenced the old Model T. It's easy to find stuff on the LS, but the older you go and the further back you go, who's keeping those records? Are they all going to be lost to time? And the answer is no. You guys have got that information.
Absolutely. And actually just this weekend, a member and a friend sent me a text of a book that he found in moving a shop that went back to the 40s. So it was how AERA could help you. It was an advertising promotional deal, and some pretty scary things compared to how we try to work safe now, where they had the car jacked up on blocks about 4 feet high while they were actually grinding the connecting rod journals while the crank was still in the engine. So, but yeah, it's fun stuff, and it's fun to be a part of that.
Now, Keith, in your job at Total Seal, you're obviously on the cutting edge, but every once in a while something that is historic comes through. I think it's kind of interesting knowing those baseline specs, what was happening then versus what's happening now. Talk a little bit about some of that evolution.
Well, to touch on, on process and the data, I want to touch on that really quick because we do, as I said, especially now, just like Chuck said, I mean, everything that's got any kind of family or sentimental value or been a project that's been on the back burner forever, people are diving into. So we're getting a lot of phone calls from a lot of people that aren't necessarily engine people. They know how to twist a wrench. They know how to work a spanner, as we'd say in the UK, our friends over there. They know how to do these things, but they really don't know engine stuff. So they need this data. They need this knowledge. They'll call me up. I just had a gentleman a little while ago. He's working on an old 427, industrial Chevrolet. Well, I've been around long enough that I know this came out of a medium-duty truck. So this is not the same as the car 427. But yet he had no idea what ring package is on it. I did my research. I found it. So this is a great resource, for whether it's an LS now or like Chuck said, a Model T, to find that data that's there on all this old vintage, antique, whatever it is, one-stop shop, call it the Wikipedia of engines. It's a great data resource. And not only just that, I mean, bulletins, technical information. I'm not trying to sound like a commercial here, but I've used it myself, and there's invaluable information there.
Do you agree with that, Chuck? The Wikipedia of engines? I kind of like it.
Very much so. Yeah, I think that's a good summary.
Wow, very, very good. All right, so I want to get into, now that we know what the Automotive Engine Rebuilders Association is, it's been around since 1922, you guys got to be super excited about your 100-year anniversary coming up next year. I don't want to put any pressure on you since it's a year away just about, but you guys have got to have something big planned for that.
Yes, and no letting the cat out of the bag or anything here, but yeah, we're actually actively trying to put together a big bang up program for leading into hopefully PRI, and as we come into next year, we want to do some big things for 2022 and our 100-year anniversary.
Super exciting. So let's talk a little bit about a couple of the things I teased at the beginning for everybody out there. We had a little email chain going back and forth, like what would be interesting to the people who listen to Hidden Horsepower. And Chuck, if you got a Warren Johnson story, those have been popular over the first 20 or so episodes. But they pop up out of nowhere. It's been crazy. But you wanted to talk a little bit about valve seal, and Keith wanted to talk a little bit about ring seal issues that are not, meaning issues that are misidentified as ring seal issues. So let me throw it out to Keith first, and a conversation starter is needed in that I'm sure you run into a lot of people who say, man, the rings are the problem, but it maybe isn't exactly that, Keith.
Well, and I appreciate that, Joe, and this is going to, I will say, I'm going to tee this up for Chuck. And not get, I'm not going to get specific about persons or brands or anything, but I'll throw this one out. And we kind of go back to what I've said so many times about rings. And I'm sure other companies say the same thing about themselves, but I like to say we're the redheaded stepchild of the engine, because anything that goes wrong, it's a ring problem. And I've said this before: flat tire on the race car trailer must have been a piston ring. Shot one out the tailpipe and got stuck in the tire. I mean, it seems from my side that it's always a ring. But I have a very good customer, does a lot of 4,600 bore big block Chevy stuff, mid 500 cubic inch, super comp, that kind of thing. And a couple of years ago, it's about 3 years ago now, he starts having a smoking problem. And only at idle, only at a high intake manifold vacuum time. Throttle plates are closed. It's trying to make as much manifold vacuum as it can. And it's not bad, but it's a little puffy. It's not clean. Exhaust ports are a little wet. Again, not soaked, but they're not what he's used to seeing. So I work with him. I send him a profilometer. We look at bore finishes. Is his cylinder finish spot on? No, but you know what? It's pretty darn close. He worked, not enough to create this problem. And we're playing with oil ring tensions. We're from 10 pounds all the way up to 20 pounds, and nothing's really making a difference. He starts playing with how the cylinder heads drain back locations. I mean, this goes on and on and on, trying to dry these things up. And again, through many, many conversations, he really starts cutting down the amount of oil that's going to the valve train, because we've talked about rings. He's done everything I can come up with at the bottom, and it just doesn't make a difference. So it's like, it's got to be in the heads, and he swears, no. Same thing I've always done. It's all the same. Can't be upstairs. And he really, really starts cutting the oil. I mean, he's done galley restrictors, restricted push rods. He's really cut the oil volume down to the top end, and lo and behold, it really starts cleaning up. Through all of that process, he really, really starts examining this thing, and he finally sees it. It's got oil coming down the exhaust guide. He goes through his, we'll say, due diligence, really starts looking at parts, and he starts chopping valve stem seals up. And where all of this goes is his supplier of the valve stem seal, because he actually had a couple engines that were dry as a bone that were the same part number, but older versions of the seal. They changed the profile of the seal where it met the valve stem. It went from being tapered, kind of like a tapered face second ring, something that's going to scrape oil off very nicely, to a flat face, even though the part number did not change. He contacted that company. They said, oh, yeah, we did that. We came up with a new part number. That's actually the new part number for the old style, and went back to that, bang, dry as a bone. So my whole long story here was his perceived ring problem that he fought for years was never the ring. It was the valve stem seal.
Yeah, absolutely. There's plenty of opportunity for that. Actually, I think I sent you a little bit of a snip on the dynamic interface between the valve stem seal and the valve stem. Many things that actually get overlooked in that are also like the materials. I went through a deal that ended up being $1 million warranty over a period of time on a particular stem seal, because the idea was hey, if Teflon is great and fluoroelastomer or Viton is great, what if you mix these two? Well, and then the seal took a compression set, and you end up with that flat interface that you're talking about, instead of a wiper edge or a nice tangential load being applied, because you have that point of contact. And then now this thing just took a compression set, so it got flat. So the surface finish of the valve stem itself tends to have a adverse impact on that as well. So yeah, those things, it's easy to always blame the ring. I hear that on the tech line all the time as well, but being cognizant of, the stem interference, like if you use a aftermarket stem that's a different diameter than what was originally used in the engine, you may lose tension against the seal, or you may increase the tension. And then, if you take a look at a garter seal, this is just like on a crankshaft seal. If I change that dimension, what is that garter spring doing to the shape of that seal lip as it contacts the valve or the crankshaft or whatever? So those can start to contribute to oil consumption. If you go back historically, again, we're talking like a Model A engine as opposed to something new. This happens all the time, and I'm sure that you hear some of this, is someone's restoring an old engine, but we're so accustomed to oil consumption at today's standards. So they get a 70s 350 Chevy that just had for a valve stem seal, it just had an umbrella or a shedder. So, the terminology is a bit messed up in what we do anyway with valve stem seals anyway, because they're a metered leak, right? Mm-hmm. So early on, they were basically, again, it was an umbrella. It just covered the valve guide, and it shed off oil that was leaking through the retainer and off of the the valve springs. And then we moved later to like the ring and band seals. The concentricity wasn't great, but hey, it was better than just a shedder. And then jump forward to modern stuff where we trim the guide down where the OD is correct, the height is correct. We use a lot of the top hat seals. And we've had to improve valve stem surface finishes. If you look in the 70s, valve stem seal surface finishes were still 24, 28. Prior to that, they actually used the stem to retain some oil because they weren't chrome, things of that nature. And you look now at modern valve stems, they're down to a surface finish of like 16 max RA. More often than not, you see them at 8 to 10. So what does that impact? So, I've actually shared a lot when we're looking at oil consumption, use that engine oil dye and then, take your exhaust manifolds off, take a black light, look in there. Hey, do I have a bunch of oil moving past the valve stem seals? And you can see it in the exhaust ports. I know it's a pain sometimes to get the exhaust off of late model stuff, especially if it's turbocharged, but it is a good tool to see that the valve stem seals are working well. That reciprocating action is pretty tough on the seal lip, so you do need to make sure that you're using the right size stem diameters, that you have the right surface finish on the valves, nicks, any kind of damage. You got to be hypercritical in the inspection of that.
Yeah, no, I was going to say you've definitely touched on some things. I mean, it's funny. As hard as we've been working on, educating the consumer about surface finishes, bore geometries, this interaction of how all these parts work together. I mean, Chuck's saying the same thing right now about the valve guide, valve stem seal interface, that, you can't just throw these parts together and expect it to work correctly, because that's, the fallback from my side is, the guy's having a problem, and the answer is, well, my guy put new valves and seals in it, so that automatically makes it right?
Right.
Absolutely.
Right. My guy did it, man. It's done. The job is done.
My guy did it, it's got new valves and seals, so it's got to be good. So that's a perfect, we'll say, carry on to what we do, that you can't just throw all this together. There's surface finish numbers. We've got to make sure, the pilot holes are correct. That you open my eyes. And one of the things that you open my eye to as well is, the set that the stem seal will take. It can take, we no longer have that scraping, edge. And you were talking about small Chevys. I mean, I remember back when the only thing they had on them was an O-ring. So.
Right. You vacuum test the retainer cap and the O-ring.
Yep. It's like, hey, it's just got an O-ring on it. That's all there is. But no, very, like I say, excellent, information, because it is, all of these things, everything has to work together, and, at any deficiency. And as I'll say, hey, they're pointing at us again, and I'm going to use the dye question, because that's excellent. That's something I know about, but I really haven't recommended that much in the past, to try to see that trace, see where is that consumption coming from. Is it coming from the bottom? Is it coming from the top? Where is it coming from? And like you say, that's a place that I don't know the cost of that, but I can't imagine it being too cost prohibitive.
No, it's actually very affordable, and it's very available anymore. Most part stores have the little small, the one-use container. So, years ago you had to buy a big bulk supply of it, but most part stores, like places like Goodson, they sell the small bottles of it as well. So it's readily available now. The other challenge with valve stem seals is where they're at today in the modern engines. The amount of oil that's just flooded on them all the time, dual overhead cam, it's totally submerged in oil. So I think, we just need to educate people more that, hey, that is a true area of concern when it comes to oil consumption, because they have a tough life. If when installing valve stem seals, one of the areas that's often overlooked is, so we make sure that it's got some interference fit on the OD of the guide, right? But when we replace guides, if we don't pay close enough attention, that the underside, so that the rubber element that's under the steel shield and under the garter spring, that actually has to be loaded so that you're sealing on the top edge of the guide. So if that thing is totally submerged under oil, then oil can migrate under the valve stem seal body and over the top of the guide. So you need to make sure that both areas of that element are sealing against the guide, but you can't have the guide up too much or it distorts it, or if it's down too low, it's not in contact and it sucks oil. So attention to detail, that fits in so many places all the time. What gets measured gets done, and attention to detail. So we talk about cylinder bore finish a lot, but there's guide bore finishes, there's valve stem finishes. The OD of that guide's got a prescribed finish that it should have so that it doesn't migrate oil as well. So
one thing we've learned on Hidden Horsepower is controlling the oil is very important, from things as basic as keep the oil on the bottom of the ring to now what we're learning in terms of oil migration, etc. But guys, how does someone turn this into a reality? Keith, you mentioned the guy, right? Like, my guy did it, man. It's done. The seals are done. They're in there. You put them. They're new. How do you approach your engine builder and, I don't want to say challenge their knowledge, but say something like, hey, are you doing this right? Like, how do I know you're doing this right? Like, how are you doing this? Like, what's your information? What tools? Like, how does that conversation go down?
Cautiously, very cautiously. You have to, again, have the confidence of the guy to be able to talk to him. He has to understand that, though I'm not an expert and I don't pretend to be, I do deal and work with a lot of experts, and I can bring him information from other people like like Chuck and guys that I deal with. Hey, so-and-so was having a problem like that, and he found this. And, try to get them to look a little outside of the box and just saying, oh, no, I put them on, they're good. So you kind of have to work with them, make them, we've done everything to the bottom end we can. We've isolated that. We know that's not the issue. It's got to be over here. Though they're confident it's not up here, we have to look at it. And I'll throw two perfect examples out ahead. One gentleman that kept having a problem, and we've done everything we can think of to the bottom end, to the point we're looking at, rod side clearances, bearing clearances, pump volumes, everything we can think of from a windage point of view. Are we over delivering oil into the cylinder? We've checked all those boxes, but it keeps coming back to the heads. And come to find out, somewhere on this particular engine, at some point in time, when they knock the guides in and out, they actually put a little groove or trench in the head where the guide gets put in. So even though they've put guides in, nobody really took a look and looked down and said, hey, look at that groove, this spiral that's going all the way down, that, once the guide's in, it's still a pathway around the outside of the guide. And that was his problem. I had another gentleman, went round and round and round, circle track engine. It had oil sprayers. He blocked the sprayers. We did all these things. And come to find out, again, he was just tapping the top of the valve stem seal with the retainer. It wasn't getting into coil bind. It wasn't there, but at operating speeds, it wasn't enough to damage the seal. It wasn't destroying the seal. But when he started really getting a look at things, he goes, you know what? That's actually tapping the seal. And that's exactly what it was. And ended up having a couple of other guys running a similar combination of stuff on a same cylinder head, having the same problem, and it ended up being the relationship between the retainer and the guide seal. Once that was changed, problem gone. But again, hours and hours and hours spent. One particular gentleman, I can't tell you how many different pistons and different rings, different bore finishes. He fought this for a couple of years, and it was the bottom side of the retainer tapping the valve seal.
So yeah, I've actually experienced a similar issue. So more in the production engine rebuilding side of it, it's very common to use oversized valve stems. So if, again, as I mentioned earlier, that's got to be factored into the interference load on the valve seal itself. But the relief grind area, Keith, is as like when they would make an area that you could put the keepers and the retainer on. Well, they don't really know exactly where that area is going to be when they're making that oversized stem. So they just throw out a number and say, okay, I'm going to move that down 3/8 of an inch. And then that interferes with the valve stem seal. And now you have a pump instead of a seal.
Oh, yeah.
So, yeah, you can totally see where, again, it's attention to detail. I know one of the earlier questions was about how do you convince the member customer that it is something else. And I think that's always the opportunity for us did you do a leak down test and a crank and compression test? That way they don't feel so bad about it being something that they did mechanically. Hey, if I get good leak down numbers, my valve, mechanically, the valves are seating, the rings are seating. I can do an upper and a lower cylinder leak down test, and I've got good sound data there, and so I have numbers to quantify my cylinder bore surface finish. I got numbers to quantify my seal. So I need to look other areas, and that's, what we always try to do is, not accuse, but, sometimes we don't know what the critical to quality checkpoints are to measure. So when we get more people involved, what, actually, we were talking a little bit about blueprinting engines today, the conversation of what do you measure? We think of the common things, block height's the same end to end, side to side. But what about surface finish of the crank housing bore, the cam bore? So you have to know enough of the other things to draw conclusions and see if they are going to impact the performance. So that you don't know what you don't know is always so relevant.
And that's why they're listening to Hidden Horsepower, subscribing on Apple Podcasts, Spotify, SoundCloud. Chuck Lynch, our guest, the Director of Technical Services at the AERA. And you guys are always looking for new members, correct, Chuck?
Absolutely. Absolutely.
People that are looking for that bit of information. So let's talk about surfaces and ring seal. Keith, we're always talking about, you mentioned the profilometer, and it's about monitoring and knowing that surface and the relationship between the ring. And that seems like a very common thread through an entire engine, high performance or otherwise, like whether it be a gasket surface or the valve surface or the cylinder wall surface. The only difference is cylinder wall is where the power is made. Or am I wrong?
Yeah, it's an important part of it. It's a place where, we can lose power because we're not maximizing what we have. Is it to say that you can have a less than optimal bore finish and have an engine that runs good? Absolutely. Can it have good oil control? Absolutely. It gets done every day of the week. But it is as good as it can be. Is it really all it can be? And there's power to be found there. I mean, there's a fair bit. And same thing goes with other issues. Chuck was saying, like he was talking to people today. I'm working with a guy yesterday with a very high boost, high fuel load diesel performance application, and going over all of his issues yesterday. And, like Chuck said, talking about leak down numbers, top and bottom of the bore, you go through this process of questions and answers that come back. And after we've bounced all these things back and forth, I promise you, that his RVK numbers are not his valley depths. They're just not where they need to be for his application. His process that he has, I think, is good, but I don't think he's getting the numbers. I think, he's got to get a profilometer, which he is doing, and he's going to check them. Now, could there be some other things? You betcha. But having these tools, we now know for sure we have data that says it is or it isn't. And if it's not that, then we have to go down the path to something else and find it, because there's always an answer. We just have to keep digging far enough and working with these guys, and almost all of them are always, they're open. They want to talk about it. They're open to have questions asked, throw their opinions back, and that's what we're all about, is questions asked and answered, and finding, drilling down to what that problem is, whether it is what they thought it was or something completely different.
And Total agreement. I'm going to kind of segue into gasket surface finishes a little bit. We speak to surface finish in the cylinder bores often and how valuable the profilometer is. And, if folks have the profilometers, they can also look at their gasket surface finishes. They're very, very well documented parameters around surface roughness and surface flatness. With the profilometers, we can provide the data that shows where MLS gaskets would typically be 50 to 150 RZ is kind of the sweet spot. We've got a maximum of like 400 RZ that is shared with the conventional paper clay composite gaskets, where the RZ, RA parameters, we can share those. You can take a look at waviness, WT. There's parameters around that. The MLS gaskets have really changed how we have to look at flatness across the board, because old, more, I'm going to say soft gaskets, the conventional paper clay or the graphite gasket with a standard folded over armor, could conform to irregularities in the surface more than the MLS gasket, which acts more like a steel shim or a spring. So the waviness is something that people should really take a look at, and you can do that with it's called Fuji impression paper, that will actually show you how the load distribution is across that surface with something that you can just bolt in place as well. So again, the numbers matter, and we have the tools to measure. And the same profilometer that you measure the cylinder bore finish with, you can measure the gasket surface with. Seal housings. Going back to seals, the OD of the guide's got to have a certain roughness. The ID of a crank housing bore for a seal has to have a certain roughness. So that one tool can bridge a lot of those gaps and make sure that you are headed the right direction. And when we have these questions about, where could that oil consumption be coming from, that tool can answer a lot of those, whether it is surface finish of the bore, the gasket surface, the valve stem, or the piston rings.
This feels to me like the blocking and tackling of engine building. And as much as trick intake systems and turbochargers and all that is the quarterback, the wide receiver, the sexy stuff, like without what we are talking about right now, you're not going to have the foundation to make any of that other stuff work.
Right. No good air pump, no good engine.
Simple as that. Keith, any final questions for Chuck as we start to wind up this episode? I know I want to delve in, Chuck, just to warn you, at the end of every episode of Hidden Horsepower, we always ask our guests to give a little wisdom to the next generation, so start stewing on that a little bit. But, Keith, is there something that you'd like to hear Chuck address that he has yet to?
Well, there is a question that I have for him, and it's kind of an observation and a question, but I also wanted to comment to Chuck that one of the things that I do, we do, again, don't want to sound like a commercial, we do sell profilometers, and I set them up before they go out. And that is one of the things that I do explain to everybody. Hey, this isn't just for cylinder surfaces. You can do, the decks, the cranks, the tunnels, the housing bores, as you said, valve guides. So these are all parameters that can be turned on in these machines. You brought up, the RZ, the peak to valley heights. These things will measure a lot of different things. So for those out there that already have them, hey, keep in mind, it's just a matter of, it's a quick thing. If you're not sure, you get a hold of myself or Chuck, or, we can walk you through how to turn additional parameters on and off. It's really not difficult to do. So you can add all these things to your tool belt, because as Chuck said, the house is only as good as the foundation. We can add turbos and nitrous and all these things to it, but if there's deficiencies in there, they're going to show up. And the more, we'll say the more efficient we make it, the more power it's making, the more likely you're going to see those deficiencies. So, we've got those guys that are just always fighting a problem. If we dig deep enough, we can usually find the root of that. But one thing I wanted to touch on with Chuck is, this company was started by Joe Moriarty Sr. Back in '67, and I don't have it here anymore, but I wanted to throw this at him. Joe actually designed and patented a valve guide back in the day that the seal was in the bottom, not on the top. And so you actually allowed the crevice to fill with oil to cool the stem, to cool the valve, and then the seal was actually in the bottom side of it. And I think a company called Signal picked up on that maybe 8-10 years ago. I know the patent's long expired, or I believe it is. And that was a really, really cool design. I know the problem again in Joe's where the polymers just weren't there. You couldn't find a seal that would handle the temperature at the time. And where I'm going is, has anybody picked up on that kind of technology? I've also seen valve guides that have O-rings on the outside of the guides now where it meets the cylinder head surface, trying to correct that interface. So just wanted to get your comments on that.
As a matter of fact, yes. Dana, the Victor Rhines Dana edition, they have a facility in Avila, Indiana, where they engineer valve stem seals, and they have some of that technology and some of the stuff that I've seen more recently. Gentleman Alex Williamson could probably really share some insight on that. But yes, and I think probably the first place I seen that was actually in NASCAR.
Absolutely.
Very interesting in that the evolution. I can't help but think about Joe, who was designing all this stuff but limited by the technology of the day.
Yeah, absolutely. After Joe's passing, they were digging through all his papers. Joe didn't get rid of much. Let me tell you this, and man, God bless him. He was kind of a pack rat. He kept everything and found all the original drawings, all the original patent applications. So it was really neat to see that. I'm not exactly sure what the dates were. I'm sure it was in the 70s at some point in time, but it was great to see all that, all that stuff. And he had a lot of them. He had quite a few patents under his belt. And like I said, unfortunately, I think with many patents, the idea is there, the technology just hasn't caught up with it.
That makes perfect sense if it's the first of its breed. Chuck, is there any issue, any subject that you wanted to throw out on the table that we did not quite get to on this edition just yet?
No, I don't think so. I really appreciate the opportunity to be on and share who we are and what we can bring to the industry, and look forward to more opportunities working with yourselves and seeing some new folks come into the fold.
Tell us about the Engine Professional podcast. What do you guys talk about on that one? And I would imagine, we've got podcast listeners, and I think the whole idea of the podcast community, I've got a podcast where I'm talking to drag racers, and we have a good time. Like, if you listen to one, maybe you end up listening to another, and I would feel great about our Hidden Horsepower listeners checking out your podcast. What do you guys do on there?
So we do speak more specifically to maybe a subject about the engine remanufacturing, rebuilding processes. So, for instance, we've had measure twice, cut once, because we're not necessarily so much performance. So just general machine shop practices. Hey, if a head comes into you, maybe take some pre-measurements because they're trying to use more of the parts over and so forth. So we started out with kind of who we are, who the history is and stuff, but we're getting into, just picking out a particular subject that may be hot on the tech line at the time and sharing that information. So like Hidden Horsepower, it's definitely geared toward the engine building. And there's not too many podcasts out there that are that dedicated to that. So, love listening to Hidden Horsepower, and ours is actually kind of fits the same bill.
Fantastic. I absolutely love it. Hear that, Keith? Isn't that great?
Oh, yeah, it's absolutely fantastic. Chuck and the whole group there, they're so vested into getting this information out, getting that data out, and, because the bottom line, the rules that apply to rebuilding apply to racing as well. I mean, it's all about sound practices, making sure like you say, measure twice, cut once, or in my case, cut once, measure, whatever. You come back and go, no, that didn't work. Better do that again. Do we got some extra of that? Just kidding. But getting that data out there, getting that information out there, sharing that information, it is such a great resource. They work so hard at this. I've used their system, will say so many times, to get that data, because you just kind of scratch your head. And some of them, and let me say this, they really vet what they have, because there's information out there that I've gone out, searched, try to find, I get it, and I'm kind of like, I don't know, that doesn't sound right to me, and then got with them, and no, that's not it, it's this. So I don't mean to keep going on, and again, don't want to sound like a commercial, but what a valuable resource.
Absolutely, and it is kind of a little bit of a commercial. Let's face it, it's wrapped in entertainment, but we're trying to make sure people understand that there are the correct places to get information, and that's what we're talking about. Organizations don't stay together for 100 years giving out bad information. That just doesn't work. All right, Chuck, this is the point of Hidden Horsepower, where the next generation of engine builders are going to be solely focused on you and what you have to say in form of some sort of advice. I'm thinking about the young you that's out there that maybe doesn't know that he wants a career in machining, engine building, performance. What advice would you have to that person?
If you're an auto enthusiast at all, I mean, there's still tons of opportunity in schools and education out there that can give you, it's a stepping stone. Maybe you don't stay in the engine machinist side of it, but maybe you end up with a race team or something of that nature. And we have a lot of those participating schools that administer the engine machinist certification program that we have, but the skills or the tech programs out there, using your hands, they pay well, and like the micro outreach and things of that nature. There's nothing wrong with busting a knuckle and getting your hands dirty, and there's plenty of opportunity out there. When I used to be involved in a project Lead the Way program with high school students, getting them into CNC programming and machining, that's what my son ended up going forward with. He does some stuff in the automotive industry, a lot out of the automotive industry, but the skilled trades do pay well, and pursue that. But I'd say we're a bit selfish in that we want to get the folks into this industry, into the engine repair industry. And again, we've got 74 schools that are participating in the certification program that we offer. Most of the production engine rebuilders are using it for continuing education and their operations as well. And they're trying to get those same young people too. So we're pushing very hard to that, and there can be a lot of fun here. If you've ever been to the racetrack, my daughter, my son, I drug them around to racetracks. There's a lot of fun to be had there. So, not only can it be rewarding and compensating, but it can be fun.
There you go. The family that races together stays together. I always say it, and I have found it to be true. Chuck, thank you very much for joining us on this edition of Hidden Horsepower. Really appreciate what you've been doing, and this is like our third show together, and so I feel like I really know your knowledge and delivery, but every time I speak with you on the air, I always end up learning something, and that's the case with Keith as well. You guys are amazing resources. I'm honored to be able to sit here and learn from you guys along with our audience. So thank you for spending the time, and I really appreciate you coming on Hidden Horsepower.
Thanks for the opportunity, Chance.
Thank you, Chuck. We really appreciate it and look forward to doing this again. We'll tackle another subject and reel you back in.
Thanks a lot.
Thank you, Chuck. There he goes, Chuck Lynch, with us here on Hidden Horsepower. Keith, That was fantastic. And you guys were wearing out my tangential lobe a little bit, but I feel like I kept up. It's the basics. It's the blocking and tackling. You've got to get these things right if you're going to maximize your situation. And if you've got oil that's out of control, that's not a good thing.
No, never is. Whether it's under the rings, above the rings, in the valve train. As we both said in comment, it's about this foundation. And, if you're only asking this engine to put out a small percentage of its potential, you can get away with a lot of things, but when you start turning that potential up and you're asking for it to become more and more and more efficient, again, those deficiencies show themselves very quickly. So everything, as Chuck mentioned, it's all about attention to detail. It really, you got to look at everything, because the one thing you don't look at is the thing that's going to bite you.
And I love the fact that they've been around for 99 years, closing in on the century mark. Any organization that can do that, pretty amazing. And the fact that people can find out information for engines just across the world, pretty amazing. AERA.org. And I recommend checking out Chuck's podcast as well. Keith, this has been another great episode, my friend. We've had a lot of fun. Let's say somebody's out there listening to their first hidden horsepower, and they're building an engine, or they've got an engine builder that they don't want to be cautious with, and they are looking for a new ring package. What should they do?
You just need to reach out to us. You can call us on the toll-free 800-874-2753. Reach us at our website, TotalSeal.com. Myself and all the other guys' email addresses are on there. You can reach out to any of us, but the bottom line, call us, email us, smoke signals, whatever you got to do. Reach out, ask us the questions.
Keith, great job as usual. Thank you so much.
Thank you. I appreciate you having me.
He's Keith Jones, the Director of Technical Sales at Total Seal. I'm Joe Castello. You can listen to my podcast, WFO Radio, all the same places: Apple Podcasts, Spotify, SoundCloud. We interview the stars of NHRA, Camping World, drag racing. We talk to some NASCAR stars. We have a great time. If you love motorsports, you'll love it. That's going to do it for this edition. Stay ready. More episodes coming soon. Hidden Horsepower, presented by Total Seal. Thanks, everyone.